Okay, so what we're doing here with this 1 and 2 and simplifying those is to show you like what should happen when we're working with the elimination method. Because what should have happened in number 1 is what? Did anything eliminate? The y's eliminated, didn't they? Because when we actually simplify this, I can have the x's and the y's trade places. And I can see that now these guys can be combined and that becomes not 5x but 6x. And this becomes what? 0y or 0n. So basically, whether you write it as 0 or you write it as 0y, 0 times y is what? 0. So we still end up with 6x plus 0, and 6x plus 0 is just 6x. So that expression should have really simplified down to 6x. 2 and negative 2 are opposites. When we add opposites, they become 0. So the y is eliminated. In number 2, you had to do some distributive property first. So after you do your distributive property, what does the expression read? 2x minus 2y. And then we have our minus 2x plus 7y. Changing it to add the opposite, I can have the x's and the y's trade places. And then I can add x's together, and what do we get? 0. They cancel each other out, don't they? They're opposites. We really get 2 plus negative 2, which is 0x, which is 0. What happens over here? What do we do with our y's? 5y. So we're really adding 0 to 5y, which just becomes 5y. Our x is eliminated this time. So in the elimination method, that's exactly what we're going to be doing. We're going to be adding. And the goal is one of the variables will eliminate with either the x's or the y's. And then we'll be able to move on solving it. So today's is going to seem really easy, hopefully. And it kind of is. Yes, will it get more complicated? It will, but this probably still is the friendliest method for solving systems of equations. But typically, this is when it works the best, when the equations are in standard form. So when the equations are in standard form, if the x terms are opposites of each other, or, not both, or the y terms are opposites of each other, like just happened up above in number 1, the y terms were opposites. In number 2, the x terms were opposites. So they ended up canceling each other out. If we look at it and we say that that's the case, one or the other are opposites, we can just go straight to adding the equations together. So what I want us to do down here is we're not really solving these right now. I just want you to look at the system of equations. First one, we have 3x minus 4y equals 12, and then the 2x plus 4y equals 13. Are both of those equations in standard form? What's standard form again? Anybody remember? What does standard form go? Rachel? Okay, well, there is an A in it, and there is a B in it, and there is a C in it, but there's more than that. Macy?
AX plus BY equals C.
Yeah, AX plus BY equals C. We have X's and Y's together on the same side of the equation. A representing how many X's, B representing how many Y's, C being the constant on the other side. So are both of these equations in standard form? The X's and Y's are together on one side, the constants on the other. So they're in standard form. So then our next thought would be, oh, well, the elimination method then would be a good method for this one. First question I have to ask myself is, are there any opposite x terms or opposite y terms? Okay, which ones? The y terms are opposites. Yeah, the y terms, the negative 4y and the positive 4y are opposites. So we would say, oh, that means I can add these equations together and the y's would eliminate. They would be gone, and I would be able to solve for x first. How the next set here? Are these in standard form? Okay. Any opposite terms? Yeah, the x terms are, because this is really a positive 1x, right? There's an invisible 1 there, and the other one is a negative 1x, and positive 1 and negative 1 are opposites. So we would say, okay, since the x terms are opposites, when I add these equations together, the x term should eliminate, and I'll be solving for y first, and then I'll go back and worry about getting my x. And like in our substitution, when we substituted in, I said, if you've got both x's and y's still in your equation, we got a problem. You're not going to be able to solve it. You either had x's or you had y's in all of it, and then you were able to solve it for that variable, and then we went back and solved for the other one. So let's go to the back side and practice solving. So here's our first one we're going to solve. 3x plus y equals negative 2, negative 3x plus 2y equals 14. Standard form, right? Do you agree? Okay. Any opposite terms? Which ones? The x's are opposite. The x terms are opposite. We have a positive 3 and we have a negative 3, so we're saying, you know what? I should be able to go right to adding them together. So here's what I already set up for us, the addition problem. We're going to line those equations up as if we're maybe adding a 3-digit number to another 3-digit number. Except when we add 3-digit numbers to 3-digit numbers, we start on the right. We have to start on the right and work our way this way. This one, it doesn't matter. We can start wherever we want. So I'm going to start on the left. What happens when we add 3 to negative 3x? 3x to negative 3x? We get 0. So you know what? Just do that. They cancel each other out. They're gone. You can put 0y there. You can put 0 if you want. Doesn't hurt, or 0x, I mean, not y. You can put 0x there or 0 if you want. But in reality, they kind of just take care of each other, don't they? And y plus 2y is 3y. And negative 2 plus 14 is positive 12. So we add all of the like terms. We're just adding them in columns is all. The x's get added together, the y's get added together, the constants get added together. Go ahead and finish solving that for y. Pretty painless. Agree with me or need to straighten me out because you know you're not going to let me make mistakes anymore? Am I right? Do I have it? Do I or don't I? I do. Okay, good. Okay, now, is that a lot less painless than having to take one of those equations, solve it for x or for y, then substitute in, and get your first variable? So when they're in standard form like this, instead of having to maybe take that first equation, get y by itself, and then substitute in for the y in the other equation, all we had to do was add them together. The x's went away, and we're solving for y. Okay, so then in step 2, we need to substitute our 4 in for y in either equation. We don't have a third one. We didn't rename anything, so you have to pick either the first equation or the second equation. You go ahead and pick. Which one are you going to use? Substituting your 4 in for the y and solving it for the x. Please, what are we solving for? X or for y? So no matter which one you use, we better all get the same answer. So in what should end up happening in these is the second step actually be the solving for the second variable actually turns out to be more work. Whereas in substitution, solving for the first variable ends up to be more work. So I get x equals -2. Anybody else use that equation? Hands up. Anybody use that equation? You get your x value? Okay. Anybody use this one? Okay. What answer do we get when we use this one? What? -2? Should we? How many x values can this one have? Only one. Do we have to use both of them? No, we're not doing a check problem right here. We're doing a solving. We're solving for x, knowing now what y was. We get to use either equation. So this is a, you know what? Or you pick which equation. Which one was less work, actually? The first one, wasn't it? Yeah. Okay. So what's our solution? -2, 4. If we had solved this by substitution, that's the solution we should get. If we solve it by graphing, that's the solution we should get. This is just another way to solve it. Okay, go ahead and do number 3 on your own. Totally on your own. See what happens. Anything done? Same answer? No. Today, because I only am making you do 6 problems. Okay, give you my filter right here. 6 problems. Not only are you going to solve them, you're going to do check problems. Even if the directions don't tell you to, I'm telling you right now, you have to. We did not check the last one, let's check this one, so we can practice that again. Okay, so when we do a check problem, we have to check them back in the original equations. Well, we didn't rename these, so we don't have to worry about them not being original anymore. So we have our 3x plus 4y equals 10. We're checking. We're putting our ordered pair into the equation. Replace the x, replace the y, make sure it checks out in the first one, and we're going to do the other one also. And you will not shortcut these check problems, or I will not consider this assignment done when you only have 6 of them to do. We need a substitution step. We're not solving. We are checking. Let's see, what did I do wrong here? Oh, it's a -4 one. Okay. And we're not done until we can't do any more going down the left side or the right side, then we can say we're done checking. That one. Does it have to check out in both of them? Absolutely. This point could just be on one of the lines and not be the point of intersection of these 2 lines. So we need to do a check problem for the other one. I kind of think if some of us would have done check problems on the, well, maybe not, that might have not even have helped us. If we done check problems on the checkup quiz. So 2 plus 4 times -1. Appears to check out in both of them. incomplete check problems will be an incomplete assignment tomorrow, so. Solving, and then checking your solution in both equations, and you only have 6 of these to do. Am I gonna complicate this in the next day and Monday? Absolutely I am. It's like, they're not always gonna start out like this with their opposites and we can add them together. But today we're gonna get the feel of what should happen when you have opposites and you use this elimination method to solve that. So anybody have any questions? You got this. Is this easier than substitution? Yeah, it is. Okay, let's go to work on our homework then. And again, I'm going to be putting quizzes on people's desks that do need to revisit some problems. And again, they can either be done now and put back in the basket, or they can be done and ready for the beginning of class tomorrow, ready to hand in at the beginning of class. Katie, you come up, you're going to make your ER call. Katie, come on up, you're making an ER call. Next. See the assignment due yesterday?
Mm-hmm.
Gonna make it in the beginning.
No.
Okay, so let me get you the key for that. I think it's in the back, so you take that, I'll go grab you the key. You would like, I don't remember if I talked about this morning, you did have that lesson, I'm going to check a quiz. No, one now.
I can do it.
You like yours? Yeah. A reminder, you don't change it on the quiz itself, you rework it on the back side or on a sheet of loose leaf paper. Caitlin, go back and use the electric one, sometimes it's more cooperative. And you guys are taking this quiz now, you can get these in there, okay? Richard, you can make your ER call next. No, that one was actually wrong, but when you were checking it, you somehow, when you were checking it, when you were solving it, you somehow actually got the right y value, even though you used the correct word. So that's what I said, so this is wrong. So, -2 is wrong. Try it again. No, that time, you're here, that time, no, I don't do 7:40, 5 minutes before the doors open, 7:45 minutes. I'll do 7 or 7:30.
Oh.